Hello everyone, I am Sushant Kumar from Center of Excellence on Solar Cells and Renewable Energy, Sharda University. I am doing PhD in the supervision of Professor Pramod Kumar Singh. I am going to present my recent work which is on preparation, characterization and application of low viscosity ionic liquid doped solid polymer electrolyte. In case of solid polymer electrolyte, the main problem occurs is of the low ionic conductivity. They show very low ionic conductivity, which can be enhanced by the use of plasticizers, or you can form blends or composites, or you can add ceramics or insulating fibers, or there is one another method that you can use new dopants like low viscosity ionic liquid, which I have done in my present work. So this is the method which I have used to prepare polymer electrolyte. So I have used simple solution cast technique to prepare polymer electrolytes. First of all, I have take PVDF-HFP as a host copolymer. Then I have dissolved it in acetone, and when it is completely dissolved, then I have add different amount of ionic liquid. The ionic liquid I have used is EMIM-TCM, 1-ethyl 3-methyl imidazolium tricyanomethanate. After adding a different amount of EMIM titanium, I have mixed it on magnetic stirrer for 4 to 5 hours. Uh, when it is completely dissolved, then I have poured the solutions into the glass petri dishes, and then I allowed them to allow the solvent to evaporate slowly. I have also made a pure PVDF HFP film by using the same method. The films I have prepared are characterized by some characterization techniques. First of all, uh, you can see here the XRD graph of pure PVDF HFP film and PVDF HFP and EMIM TCM blended film. Uh, the black portion is showing the pure PVDF HFP film XRD graph, and the red portion is showing the ionic liquid doped PVDF HFP polymer film graph. So here you can see that pure PVDF HFP graph is showing uh, 4 peaks at 17.7 degree, 20.3 degree, 26.6 degree, and 38.9 degree. And these, by seeing these peaks, we can say that these peaks are showing the semi-crystalline nature of PVDF HFP copolymer. And in case of ionic liquid doped polymer film, you can see that the two peaks at 26.6 degree and 38.9 degree are disappeared when ionic liquid is doped inside it, and the other peaks are broadened, so which is showing that the crystallinity of the PVDF HFP copolymer is decreasing when we add ionic liquid in it. And in the right side, you can see the FTI spectra of pure PVDF HFP film and ionic liquid doped PVDF HFP polymer jelly electrolyte. So here you can see that the black portion is showing the pure PVDF HFP film, and red portion is showing the ionic liquid doped PVDF HFP film. Where you can see that the peak at 487 centimeter inverse gets downshifted to 481 centimeter inverse when ionic liquid is doped into the PVDF HFP film, and the peaks at 524 and 976 centimeter inverse observed in PVDF HFP are disappeared while we add ionic liquid inside it, and the peak at 872.74 centimeter inverse, which is corresponds to the amorphous phase of the polymer, is gets narrower when we add ionic liquid inside it. And there are some additional peaks are shown into the ionic liquid doped PVDF HFP film, which are at 2160.23, and also at, at 3000 and 3156 centimeter inverse, which is which are due to the anion and cation of the ionic liquid. So this data, this FTIR data is showing that ionic liquid is perfectly blended with the copolymer PVDF HFP. Uh, Here you can see the TJ and POM micrographs. Uh, in TJ graph, you can see that in case of pure PVDF HFP, the copolymer is stable until 430 degrees Celsius, and then there is a drastic weight loss occurs till 505 degrees Celsius, which is due to the decomposition of the copolymer. And after that, we at 600 degrees Celsius, we have almost 20% of the PVDF HFP it is remaining. And in case of ionic liquid doped PVDF HFP, first of all, you can see that till 100 degree there is 8% of weight loss occurs, which due to the water and moisture present inside the film. And after that, it is stable until the 261 degrees Celsius. And then there is a fast weight loss till 380 degrees Celsius. And in the last, we have almost 50% of the film weight remaining. So and in the POM graphs, you can see that pure PVDF HFP film graph, micrograph is smooth, showing the smooth surface, and it is also bright. But when we add ionic liquid inside it, you can see that there comes some roughness inside it, and some black dots and black portion arrives, which is showing the that the crystallinity of the pure PVDF HFP is decreasing when we add ionic liquid inside it. And also you can see there are some scratches on both of the graph, which are due to scratches present inside the petri dishes. This is not related to the any of the ionic liquid or polymer. There's the result and discussion of ionic conductivity, LSU and T ion. So here you can see in the left upper corner that there is a graph which is showing the Nyquist plot for the highest conductivity film, which is 300% weight film. Uh, and on the right of it, you can see the conductivity data. So first of all, we have taken impedance spectroscopy of all the films, and then we draw Nyquist plot out of it, and then we calculate ionic conductivity from them by using the formula. This is which is given here on the screen. And after calculating it, we draw a graph between conductivity and ionic liquid content. So here you can see that the highest conductivity shown by the 300 weight percent graph, which is 3.7 into 10 power minus 2 Siemens centimeter inverse. And here you can see in the lower left side, left corner, there is a graph which is between the current and potential. This is LSV graph of the highest conductivity film. So this is here you can see that it is stable from minus 0.5 to 1.5 volt. That is almost 2.0 volt. And so the film, we can say that the electrochemical stability window of the 300 weight percent film is 2 volt. And from the T ion graph, which is present in the right of it, which you can see that we have done current versus time graph, the potentiostatic graph studies. They are showing that the ionic current is the major source of current inside the films. Okay, so from here we have calculated the TIN, and we got 0.93 value of it. So there are we can see that 93% of the charge carriers are ions inside the films. Here are the dielectric studies. In the left upper corner, you can see the dielectric constant versus weight percent of ion liquid graph at the different three random frequencies. The frequencies I have chosen is 82522200 Hertz, 99610 Hertz, and 8301 Hertz. And here you can see that these graphs are following the conductivity graph trend. And in the right of it, you can see the 10 delta versus frequency. 10 delta is the dielectric loss. So here you can see while increasing the frequency, the 10 delta is also increasing, and then it attains a maxima at certain frequency, and then it starts to decrease again. This maxima is known as a relaxation frequency, and opposite of it is known as relaxation time. So lesser the relaxation time, greater the ion migration inside the film. So here we get the lowest in the order of 10 to the power minus 7 order relaxation time for the 200, 400, and 300 films. So we can say that these have the highest ion migration in them. And in lower two graphs, you can see that this is between the real and imaginary part of real and imaginary part of dielectric versus frequency, where you can see in both of the cases the uh, real and imaginary both parts are increasing with the increasing weight percent, and when we increase the frequency they starts to go downward because the dipoles are not able to follow the field variation at high frequencies. So from here I have concluded that the gel gel polymer electrolyte films are prepared using copolymer PVDF HFP, and different weight percent of ionic liquid EMIM TCM were successfully prepared by solution cast technique. The XRD and POM study indicate the semi-crystalline nature of the PVDF HFP film, which is converted to amorphous nature when ionic liquid is added in them. And interaction of ions from ionic liquid with polymer chain and functional groups present in the films are revealed by the FTIR analysis. And all the polymeric films are having ionic charge carriers in major amount, which is equals to 93% of the charge carriers are ionic. So which is confirmed by the DC polarization technique. The relaxation time corresponding to relaxation frequency is of the order of 10 to the power 7 second for the polymeric films, 200%, 300%, 408% of ionic liquid, which is indicating that fast ion migration is happening inside these films. And the value of ionic conductivity varies with ionic liquid content, and reached a maximum value of 3.7 into 10 to the power minus 2 Siemens centimeter inverse for 300 weight percent of ionic liquid in PVDF HFP. The same film was found to be electrochemical stable in 2 volt range. The dielectric plots also follow the same trend as a conductivity, and increasing dielectric constant with increasing ionic liquid is observed. The blend gel polymer electrolyte is sustainably for electrochemical devices and practically for supercapacitors. Thank you.